Welcome learner to our today's math lesson. And before we start what we are supposed to do today, I want us to begin by revising what we did yesterday. Yesterday we were trying to look at the base area and the cross-sectional area of cubes and cuboids. And later on we discussed about volume, how to get volume when you're given base area and height, and when to get how to get maybe height when you're given base area and the volume. So I've written a question here which says the area of the bottom of a rectangular tank is 180 centimeters squared. If the height is 25 centimeter, what is the volume of the container in centimeters cubed? Now what are we given? We are supposed to break this question down into some workable statements. So we are given the area, base area, which is given as 180 centimeters squared. Then we are given the height. Height is given as 25 centimeters. And then the question is, what is the volume? What we want to know in this question is the volume. So if you are given the base area, you use that formula for base area. You say volume is equal to base area times height. So the volume is not known. So volume is equal to base area 180 centimeters squared times the height, which is 25 centimeters. If you multiply this, it will give you 18 times 25, you get 0, 9, 6, 3, 0, 5, 4. Volume will be equal to 4,500 centimeters cubed. 4,500 centimeters cubed. Just to remind you, what we call base area is the length and the width. The length and the width has already been multiplied. So you only multiply that with the height. Now, if for example you are given question here, you are told, for example, the volume is a question here. Volume is 1.44. The volume is 1.44 meters cubed. We're told if the length of the tank is 1.5, the length is given as 1.5 meters. What is the width? You're looking for the width. So you need to just write, if it's a word question, break it into small workable statements that you can be able to follow. So you say volume is equals to length times width times height. Why are we using length, width, and height? Because these measurements here are length, width, and height. We are not given base area. So that's why we are using volume is called length times width times height. So our volume is given. So where it is given, replace that. So in our case here, V will be replaced by 1.44 is equals to, the length is given as 1.5 meters times, the width is not given, and then you are also given, sorry, the height. The height is given. Height is given as 0.8. So the height, width times the height, 0.8. If you multiply this and this, it's going to give you 1.2. So 1.44 is equals to 1.2 meters. Okay, so sorry, 1.2 W. Because we are multiplying 1.5 times 0.8 times W. So 1.2 W. So for us, we don't want 1.2 W, 1 W. So we divide by the coefficient of W. Coefficient is the number that appears before W. So the coefficient of W is 1.2. We divide that by 1.2 or 1.2. If you divide this well, we are going to get our width is equals to 1.2 meters. So our width is going to remain 1.2 meters. So now you don't need to be afraid when you're given a question like this. Just follow the formula. Get the formula that I gave you, write it. Where you're given base area, you're not going to write this. You're going to write base area is equals to, base area times height to get volume. Where you're given the length, width, and height, you're going to use this formula. And you're going to get the questions right. So back to what we are supposed to do today. In our lesson today, we are going to look into the cross-section area of a cylinder, cross-section cylinder. And later, we will use this to get the volume. We will use this to get the volume. Now, this is an example of a cylinder. Learners, you can be able to see this well. This is what we call a cylinder. We did cylinder when you're looking for total surface area, and so you saw it. So this is just another example of a cylinder. You can see it as this circular part, the below one, and the upper part. But on our today's lesson, we are not going to consider the two of them. We are only going to consider one, because we are looking for the area. We are going to look for only one. So, before we do that, I want us to arrange some coins here. Some coins here. Now, my coins are, each one of them is 1 millimeter. The width of this coin, the thickness is 1 millimeter. So I'm going to arrange 10 of them here. So 1, 2, 3, 4, 5, 6, 7, a bit more, 7, 8, 9, let's put them to 15, 9, 10, 11, 12, 13, 14, those are 14, I need them to align well, then 15. We can add more. To be 20. At least we get something we can be able to see well. So these are 20. They are going to be 20. So back at home, you can try that to arrange them and calculate their area. So those are 20 coins. Like that. It's not easy to arrange them, but I'll try. Yes, we have 20 coins. In our 20 coins now, Lana, we have said one coin has a thickness. The thickness is 1 millimeter. 1 millimeter is written like that. 1 mm. So if they are 10, so those are 20. If one is 10, then 20 coins will be equal to what? So it was multiplied. So the 20 of them have 20 times 1, that is 20 millimeter. So what is that 20 millimeter we are talking about? Remember, we have drawn them like this, we have arranged them like this. We have them here. The 20 of them, they are here. So if one has a thickness of 1 millimeter, from here to here is 1. So meaning if they are 20, they are going to rise up to 20 millimeter. I don't know whether you are seeing that, Lana. So the 20 millimeter becomes the height of that particular cylinder, because this is going to be 1, 2 millimeter, 3, up to 20 millimeter. So that will form the height of that particular cylinder. Assuming that the radius is 11 centimeter. Sorry, 11 millimeter. The radius of one coin. A coin is drawn like this. So the radius from here to here is 11 millimeter, meaning that the diameter is 22, and we have arranged 20 of them. Can you be able to calculate the area, the cross-sectional area? Now, I want you to forget about this, Lana. Forget about that 20 millimeter, and let's concentrate on this part. I want you to concentrate on this surface, which has a radius of 11 millimeter. So for us to be able to get the cross-sectional area is going to be, how do we get area of a circle? Because that is what we call cross-sectional area. We are only going to deal with the circle. That is how where we get the cross-sectional area from. So how do we get area of a circle? Area of a circle is given by pi r squared. So for us to be able to get cross-sectional area of a cylinder, we just get pi r squared. So in our case here, cross-sectional area is going to be pi, I'm going to use 3.14 times the radius squared. What's the radius? 11. So radius squared means 11 times 11. Lana, if you calculate this and this, you're going to get 121. So you get 314 times 121. Get 4, 1, 3, get 8, 2, 6, get 4, 1, and then 3. 4, 9, 7, 3. Then how many decimal places? We have 1, 2. So you are going to get the cross-sectional area as 379.94 millimeter squared. Remember, we're talking about area, so that is going to be millimeter squared. So now we have gotten our cross-sectional area. Let's try another question. We want to get another question. Another question, just like given a question like this: a cylinder whose radius is 14 centimeter and the height is 20 centimeter. You ask, calculate the cross-sectional area. Now cross-sectional area is going to be pi r squared. The area of the circle. We are not dealing with this other part, the curved surface. No, we are dealing with the area of the circle. That is going to be, cross-sectional area is going to be 22/7. The radius squared. Radius is 14. So 14 times 14 by 7, 1 by 7, 2. This is going to give you 44. 44 times 14, that is going to give you 616 centimeters squared. There's a reason why I'm putting centimeters squared, because this is area. So these units will change. At calculation, you get centimeters squared. You can do another one where we're given a diameter. Want to be given a diameter, assuming they have given you a diameter of 14 centimeters. So the diameter is 14 centimeters. These remain the same. So cross-sectional area is going to be pi r squared. Pi, so 22/7. The radius. Now the radius is going to change here. Remember, this is diameter. So for you to get radius when you're given diameter, you get the diameter over 2. You get radius. So divide this by 2, you get 7. So 7 times 7. Radius squared by 7, 1 by 7, 1. So the cross-sectional area is going to be 154 centimeters squared. 154 centimeters squared. So I think you have understood that, learner. Now for us to be able to get now the volume. For us to be able to get the volume, this is what you do. We have known how to get the cross-sectional area. You remember our coins? Our coins are a radius of 11 millimeter, and their height, we arranged 20 of them. They were 20, that gave us 20 millimeter as length. For us to be able to get now the volume, how do we get volume? Volume of a cylinder. Now to be able to get volume of a cylinder, we get cross-sectional area times the height. Simple as that. Cross-sectional area times height. What cross-sectional area do we get here, Lana? 379.94. So we got our cross-sectional area as 379.94. This is our cross-sectional area, then times the height. The height is 20. This decimal point is going to bring the decimal point there. This is going to remain 3799.4 times 2. Give you 8, 18 carry 1, 19 carry 1, 14, 15 carry 1, and this is going to be 7. So our volume is going to be 7598.8 But this time round, Lana, this is not going to be centimeters or millimeters squared. No, we are looking for volume. Volume is given in cubic units, either cubic meters or cubic centimeters. So what are these? Millimeters. So it's going to be millimeter cubed. We can also change these to centimeters. If we change to centimeter, we're going to get 1.1 times 2 here in our case. So now we want to identify our cross-sectional area. Let's do another question before I give you what cross-sectional area represents there. So we are going to do this question here. This question here. So how do we get volume? Cross-sectional area times height. We have already our cross-sectional area. So our volume is equals to 616 centimeters squared times the height. The height is given as 20 centimeters. This is going to give you 616 times 2. That is going to be 2, 3, 12, 32. So our volume is going to be 1,232. Then you add this 0. 12,320. These are centimeters, so units will be centimeters cubed. I think we are together line up to there. So I want to show you what is now the formula. Because here we're just using cross-sectional area times height. We want to write the formula now. Volume is given as cross-sectional area times height. Let's come down here and say, what is the volume now? What is our cross-sectional area? How do we get our cross-sectional area? We got cross-sectional area by getting pi r squared. So we are not going to write pi r cross-sectional area again here. We're going to write what that represents. That is represented by pi r squared, then times height. So that is the formula of getting volume of a cylinder. The volume of a cylinder is given as pi r squared h. Remember, this is different from the surface area. In our surface area, we said a closed cylinder is given by 2 pi r squared plus pi dh, a closed one. An open one is given by pi r squared plus pi dh. Curved surface, we said, is given by pi dh. So those are things that we need to understand. So the formula of getting cross-sectional area, not cross-sectional area, but volume of a cylinder is pi r squared h. So we are going to use this to calculate a question here. You are given a cylinder, that is our cylinder, whose diameter is 28 centimeter and has a height of 28 meters and has a height of 10 meters. And then you ask, calculate the volume of this cylinder. So you come and say, volume is equals to pi r squared h. As simple as that. The cross-sectional area times height. So this is going to be 22/7 times the radius. This is diameter. So you get the diameter divided by 2. For you to get radius, 14. 14 squared times height. Our height is 10. Simple as that. By 7, 1, by 7, 2. This is 44 times 2. 22 times this is 44. 44 times 14 is 616. Then you add the times 10. You add that 0. So our volume is 6,160. These are meters. So meters cubed. Meters cubed. As simple as that, learn. That's how you get it clear. I want us to get one question here more. And I want us to use these measurements here. You are given a radius of 1 meter and a height of 6. Height is 6 meters. Then you are told, what is the volume of the cylinders having the volume, the dimensions? These are the dimensions given. It's always good, learner, if you are given such information, just try to draw. This makes work very easier, as you are going to see. So the radius is 1 meter, from here, 1 meter, and the height is 6 meters. We are asked to use the pi. Take pi to be 3.14. We are going to use that pi. So we come and say our volume is given by, we just start by giving the formula. You cannot be able to start any question without a formula, because that's just like walking aimlessly without a direction to go. So our volume is equals to pi r squared h, which is height. So we come and replace here. Volume is equals to pi. What is our pi? 3.14 times. This means times, you multiply everything here. Radius squared, the radius is 1 times 1, then times height, 6. Simple as that. 3.14 times 1 times 1 is, times 6. This will give you up to there, it will give you 3.14 already. Then times 6. So 3.14 times 6. 4 carry 2, 8, 18. 1, 2, 1, 2. So our volume is going to be 18.84 meters cubed. So that's how we get it, man. That's how we get it. Now, in case you are given a radius that is having some decimals, let's see what you're supposed to do. Another question here, that you are given that the radius is 10.5 and the height is equals to 20 centimeter. All these are centimeter. What is the volume? You draw here. Volume. That radius is 10.5. From here is 10.5. Then these are centimeter, and the height is 20 centimeters. 20 centimeters. Can we be able to get the volume? Yes. Volume is equals to pi r squared h. That's where you begin from, learn. Now, remember, we are not going to use this pi, we are using the other pi. So our volume is supposed to be 22/7. The radius, what is the radius? 10.5 squared. 10.5 times 10.5 times our height is 20 centimeters. So by 7 gets into 10 one time, you remain with 3. So 0.5. So you get this one 0, we remove this decimal, this will remain 15. So 22 times 15 gets 0, 10, 11, 2, then 2 gets 0, 3, 330, then multiply that by 2, gets 660, this 2, then multiply that by 105. Okay, we can do this. If you are multiplying this 0, 660 times and 10.5. This one is going to remove this. So this is going to remain 105. So 66 times 105. To simplify the work, so 105 times 66. 0, carry 3, 9, 6, 0, carry, sorry, it's supposed to be not 9. 0, 3, 6. Then is 0, 3, 6. 0, 3, 9, 6. So our volume is going to be 6,930 centimeters cubed. So I think you have understood up to there, learner. So I don't want to continue and prolong this lesson. I just want to give you some practice questions. But before I do that, allow me to do one question, because what I'm going to give you is something that you need to get clear. So I'm going to do the last one. Last one question before I give you an amount of work that you'll be able to capture all this. So I want to give you a question here. The volume of a cylinder is 308 centimeters cubed. Volume is given as 308. You don't need to write these statements. You only need to break them into workable statements. If the cross-sectional area is 38.5 centimeters squared, you will always learn that the cross-sectional area is given in square meters because they have calculated the area of the circle. What is the height? So what is in the question? The height. So it's very simple, and you come and say volume is given by cross-sectional area, because here they have used cross-sectional area. Cross-sectional area times height. So our volume is here. So you replace this. The V is replaced by this. This is equivalent to this. So you say, you will not again write V here. No, you write what is given here. So 308 is equals to the cross-sectional area 38.5 times the height. The height is not given, remember? So 308 is equal to 38.5 times h is 38.5 h. So we don't want 38.58, 118, which is h. So we're going to divide this by 38.5. The coefficient of h, 38.5. So we are going to remain with our height being 308 over 38.5. Very easy, learner. You just check which one can divide. So this is a one decimal place. There is no decimal place. So you multiply with a number that has one decimal place, which is 10, both sides. This one will remove this. This will become 385. And then on top, the numerator will be 308 times 10, which is going to be 3080. And then we divide that. We divide that. And divide that here. Now we are going to use long division for us to be able to get this. So 380 divided by 385. 385. So let's try by 7. 385 by 7, get 5. 33. This 56. 56 plus 3, 59, 35. This 21, 26. 26, 95. 695. Let's add 385 to be more than what we need to be more. 385, let's see. 0, 10, 8, 0. Good. So 8 times you get 3008. So our height is going to be 8 centimeters. Our height is going to be 8 centimeters. So learner, if you are given the volume, consider the area, they ask you the height. You replace you just write the formula, replace what you have been given in the question with what is there, and you're actually going to get the answer. So I want you to do this, learner. I want to give you some practice questions. And you do that work well. So we are going to begin from exercise 86, primary maths. Now people have so many types of books for maths, but you can use the others for practice. Exercise 86. That's question number 1 to 4. Then exercise 87 on page. This is on page 143. This is on page 144. The questions are from number 1 to 5. This is just small amount of work that any learner can be able to finish and finish well. So I want to wish you well. We've come to the end of our lesson. I want you to try these questions and try to do them well. Follow the formula, replace what you are given in the formula, and calculate well. You will get the answers. So until next time, have a blessed day and enjoy at home as you continue sanitizing and staying safe. Thank you.